Welcome everyone to today's session on predictive analytics. Bruce Kolodziej here, part of the corporate sales team and information builders. I'll be walking you through a demonstration of our machine learning and predictive analytics platform, WebFOCUS RStat. We're going to walk through a use case around customer churn, utilizing a historical data set, and then we'll use that historical data set to train and test a couple of different predictive models, and finally we'll deploy that model out to a new report where we can score new customers for their likelihood to churn. One of the things to note is the differentiator of what Information Builders provides from a technology point of view is a completely integrated platform for advanced analytics, meaning really advanced analytics starts with a data set, and that data set could be in one format, one location. It also could be disparate. So we have a lot of capabilities around data access, data preparation, but also data quality, and creating what we call trusted data so that you know that the models you build are accurate. Second, we have a platform based upon open source R, so it makes ease of use for model building, model testing, and then finally, model deployment. Being able to push that model into a business intelligence application to score, in this case, new customers for their likelihood of churn. Putting these three steps under a single technology umbrella is really where our customers get predictive analytic projects off the ground very quickly, and also repurpose the platform for multiple use cases. So general purpose platform that can work on marketing analytics, it can work on risk, work on fraud, even work in manufacturing for predicting equipment maintenance. So let's start here with our historical data set on customer churn. So in essence, how predictive modeling works is I have a data set that contains a behavior that, one, I'd like to understand how that behavior is influenced. What are the signals that drive that behavior? And secondly, how can I then take that model I create and apply it to new data going forward to make similar predictions when a behavior is unknown? So here, for this customer churn example, I've got a customer identifier. I've got a flag variable here, churn, yes and no. So anyone that's labeled yes has canceled their account. Anywhere it's no, they're an existing customer. That's the behavior we'd like to be able to model. And then I've got some other demographic data here, such as age, education, marital status, gender, occupation. I have some income data, credit score, years of current job, customer lifetime value. You could have dozens and dozens of variables, both demographic and account type information, but also purchase behavior. You could have social media information here. Really, you could have a wide variety of information that you want to be able to tease out. Again, the signals in that data that are determining the difference between someone who cancels their account and someone that does not. And that's the process that we'll go through for building a predictive model. So first thing, we access some disparate data. And again, a big part of this could be an effort around data quality, data management, master data, getting that data trusted so that you know that the models that you build are actually going to be of high quality. So it's our historic data. Here, under our modeling tab, I click Launch WebFOCUS RStat. And what's nice is we have this seamless connection between the source data here, customer ID, churn, age, education, right into our model building interface. So again, that data behind the scenes could be coming from multiple sources that we've brought together, creating that 360-degree view. And in one click, I've gone from source data that's in different systems right into a model building interface here, WebFOCUS RStat in the foreground. This is our interface to R that we integrated with our overall data management platform. And what it allows you to do is interact with the R open source language for advanced analytics, but not have to code anything, not have to script anything. So we've created this interface that really covers about 98% of what an analyst would do on a regular basis, but they can do it without scripting, without coding, without having to debug code as they go through exploring that data and building predictive models. So there's a left to right workflow you can see here on the tab portion of the interface: data, explore, test, transform, cluster, associate. And eventually we'll get down here to the modeling tab, where we actually will build a couple of different predictive models. But here on the data tab, we've got some options where you can partition the data. So this allows you to separate your historic data into two subsets. We call that the build and then the test. And we default it to 70%. You could change it to whatever you like. You could certainly turn that off if you like. But that's a good best practice for testing a model, is holding out a portion of the data for evaluation. We'll get down to the last tab here. And down here is where you assign the roles that the fields play. So in this case, I've got customer ID as an identifier. The churn variable is our target variable. And then I've got a variety of inputs here. And you could have as many inputs as you want. Again, typically with a marketing type example like this, you're going to have some demographic data. You probably have some account data, maybe some spend information, but not limited to what you can bring in. And that's really the power of advanced analytics, is you really could bring in as many variables as you want, and it will let the algorithm do the heavy lifting of what's important and what's not. So move over to the Explore tab. This is a really useful step as you get prepared to build predictive models, is to kind of do an audit of the data. What do I have to work with? And this Explore and then Summary option allows you to do things like, well, what are the number of levels, meaning what's the unique value set within each of my variables? And then here we'll actually display what are the values within each variable. And I'm trying to get an idea here of, does this data look like the data that I expect? Maybe someone supplied this data for me, and I want to make sure that it has the values within each of the variables that I expect. Scroll down. As you scroll down, it gets more details. You can see things here like a statistical summary on age, and you can say, okay, I want to understand the distribution of that variable, look across the minimum, quartile, median, mean, third quartile, max. Here, for category variables, it shows me the count of each of the values. Scroll down a bit further, and I can see things like, do I have any missing values, how many distinct values, and then what's the percentile distribution. So I'm kind of looking for, making sure the data is what I expect. I'm also doing some work here around looking for data errors, and also looking for outliers and things I may want to clean before actually building models. I want to make sure that that data is what I expect, and if it's different than what I expect, I have the opportunity now to actually revise that data. And I want to avoid, in other words, building some models and then realizing after the fact that the data wasn't what I expected. So we allow you in this kind of left to right workflow to actually explore and visualize the data here with this distributions tab. So you can do things like a box plot, histogram, cumulative chart, Benford chart. Down below you've got categoric visualizations, bar, dot, mosaic. We do correlation analysis, so Pearson, Kendall, Spearman's row for understanding numeric variables and whether they're related to each other. Principal components is used for variable reduction, and there's some options here for interactive graphing. So doing things like scatter plot and 3D. Under the test tab, you can take care of things like statistical significance tests, so tests of distribution here on the first tab. You've got location and variance tests. Some of the common ones you'll come across are t-test of means, f-test of variance. We've also got a chi-square test here, which is the ability to test correlation on category variables. And then there's a tab here for data transformation, so the ability to modify the data. And there's 4 different options here we'll walk through. The first one is around rescaling, or it's another term for normalizing. Sometimes data that you are analyzing, and what we call real life data, often is not normally distributed. It's not bell-shaped, and some modeling techniques prefer to have more normally distributed data. So we give you the option here to actually derive normalized versions of the variables. Here you can take care of missing values by saying, hey, I'd like to impute or fill in where values are missing, and you have choices here of what you actually want to fill in with. You can actually put the word missing or number 0 in. You could fill in with the mean of the populated values, median, mode, or you could actually just type in a constant if you choose. Recode allows you to do things such as bin a numeric field You might want to put a bin in high, medium, and low. And here, instead of the user defining those boundaries, WebFOCUS RStat will actually define the bins for you and the width of those bins by different methods. This quantile bin, which will put approximately the same number of records per bin. You can actually do a cluster bin here with k-means, or you can do equal width bins. So these bins will be the same width, but you might have a lot of records in one and a few records in the other. But the idea is that you can try out different versions of data transforms and see which ones actually perform better in the predictive model. This option allows you to create 0, 1 indicator variables out of categories. So create a whole new set of columns that are present absence. Here you can do variable concatenation on categories, force a numeric to be categoric, or force a categoric to be numeric. And there's finally an option here around cleanup, typically here used for dealing with missing values. If instead of filling them in, you'd like to just ignore or get rid of them, you can use some of these options here. So the first 4 tabs of WebFOCUS RStat are really powerful for initial kind of exploration of the data, both statistically and visually, do some statistical hypothesis testing, and also doing some data transformations. And the better that you can understand and then shape and modify the data, often the better predictive model that will result. So now the second half of our stat, as you can see, we have 3 tabs dedicated to pattern detection. The first one is called clustering, which is just another term for segmentation. These are algorithms that will group records together based upon similarity. So common use cases are an organization may want to cluster their customers into like groups. Instead of a user defining, here's everyone I'm going to put in group 1 because they kind of behave similarly, but I'm going to put everyone else in group 2. This is a data-driven approach. This k-means algorithm is designed to put records in groups that are actually related to each other analytically. Right? So you don't have to kind of predefine them. Secondly, the nice thing of this k-means algorithm is often will uncover a group that you didn't know to look for. So this is the discovery part of machine learning. You could pass data in, and then you can explore the groups and be able to describe them, and you may uncover a group that you didn't know existed. It could be a small and unusual group, but it could be that that group of customers were always kind of lumped in with another group of customers, and you may be able to find some real insight there to treat them differently based upon their similar behaviors. Association tab is for market basket analysis. This is an algorithm that finds things that happen together or in combination, so typically used for cross-sell, upsell. If you buy product A, you also buy product B 90% of the time, so the algorithm is supplied here. You have that ability to pass data in, typically transactional data, and out will come a series of rules with those if-then rules. If you buy product A and B, then you tend to buy product C 60% of the time, so you can use this algorithm to discover those combinations of items, and then you can deploy it. You can use this as a recommendation engine, finding things that I could offer someone based upon their past purchases, but certainly not limited to retail. This could be used in healthcare for finding diseases that happen in combination. So general purpose platform here that can be applied anytime you want to uncover things that happen together or in combination. And much like the cluster tab, once you build that model, you can export it. So I may want to cluster new data as it comes in. What cluster does a record belong? Likewise, with association analysis, we can deploy that model and make again, product recommendations or what's the most next likely ailment that someone may see based upon their past. The next tab is where all of your traditional predictive models reside. If we click this drop down, you can see the modeling techniques that come with WebFOCUS RStat. And a variety of techniques in here, and they cut across techniques that are called rule-based techniques, like decision tree, random forest. You get a whole variety of regression techniques, which are statistical techniques, and then you get some other little bit more advanced techniques, such as a neural network and support vector machine. So they all do the same thing. They go about it a little bit differently, and usually the choice of model is partially by interpretation and partially by business value. One of the things you may notice is some are grayed out, and what we do is give you guidance on the proper technique based upon the data fed into WebFOCUS RStat at the moment. So when we let you build models that are appropriate for the type of target data that you fed in. So in this case, let's build a decision tree for this customer churn data. We get some parameters here that you certainly can adjust. For the moment, we'll leave them as is, and I just choose decision tree, click the run button, and we built a rule-based decision tree. A couple things to point out right here. Variables actually used in the tree construction. So the algorithm goes through the 10 or so variables that were available, and it says, I'm going to filter out 7 of them, and I'm going to say age, marital status, and years of current job are the 3 most important to discerning between those that customers that churn and those that do not. Doesn't mean that the other variables are completely unimportant, because you can adjust these parameters and you can attempt to push more variables into the model or reduce the number of variables in the model. In other words, you can make the rules simpler or more involved. And you can also click the draw button here to get a look at what that decision tree looks like, and you can put it side by side with the actual rules themselves. So I can actually see, based upon rule, this is rule number 2, rule number 6, rule number 28, 29, 15. I can actually see those rules over here on the left. So this is the algorithm separating all of the historical data based upon those variables and the values set within. So it's determining these cut points of marital status, years of current job above and below 5.5, above and below 1.5, age above and below 30. That's the power of the algorithm separating the records out into these subgroups here. So if you look at Rule 15, there's 69 people that match this branching of the tree. 94% of them cancel their account. So that's a really strong rule for someone canceling their account. Here's another one, 249 people, nearly 80% of them cancel their account. And you can see the 3 rules here on the left. Those are dominated by those that did not cancel their account. So you notice that we build predictive models, it's not always to make a prediction about a behavior, because we want to build a model in this case to show the difference between 2 behaviors. And you could use this for targeting people for a retention offer, but you also could use the customers that are unlikely to cancel their account and say, let's make them a cross-sell offer or an upsell offer for an additional product. So at this point, I could say, let's build a second predictive model. Let's build a logistic regression, run the model, scroll down a bit. And regression is a little bit more of a statistical technique. It doesn't provide me with a set of rules. It provides me what's called an over table. But we give you some insight here into actually what variables are driving that model. So I can see here by these asterisks. 3 asterisks is the most important variable. 2 asterisks is next most important, and then 1, and then typically those without any asterisk are really statistically unimportant. You may not get exactly the same list here of importance that you will in the decision tree, but that's okay. Part of model building is a little bit of trial and error and trying out different modeling techniques on the same data, so I can, again, balance model interpretation with model performance. If you jump over to the Evaluate tab, now is when I can actually evaluate the predictive power of both of these models. You see, WebFOCUS RStat keeps track of the models we created. We created a decision tree and a regression model, and I'm now going to run both of those models back through the holdout or testing data and see how accurate each is by way of an error matrix. I click Run, and I can see here the decision tree results at the top in terms of count. So there's 2 ways to be correct. I can predict no when the actual is no, and I can predict yes when the actual is yes. But then there's also 2 ways to be incorrect. Predict no when the actual is yes here, predict yes when the actual is no here. So we give you an idea of kind of where the model is doing well and where the model is struggling a bit to make predictions. Count here, same data, but in terms of percent. And if you look at this off diagonal, we'll actually show you the overall error rate. So for this first model of the decision tree, the error rate is 19%, which means the flip side of that is that the model has an accuracy of 81%. So it's a good way, it's a good typical measurement people like to know is, hey, how accurate is the model when I run it through, again, testing data that was held out. Second, When you scroll down a bit, you'll see the same information, but now for the regression model. So in terms of count here, and then in terms of percent, I've got an overall error rate of about 21%. So slightly higher than the decision tree. And typically, again, you want to balance interpretation with model performance. You might say, hey, this of the two, this decision tree performs a little bit better. I have the choice now of building some additional modeling techniques on the same data to see if I can improve that error rate, or I now have to go back and do some data transformations and see if I can improve that predictive model performance. So there's analytical performance, but certainly you want to take note of the business value. You know, you may not need a model that's 90+% accurate to get real business value out of it. So these measurements as well can be used to compare to what's in place today, even if there's no model in place today. How do we make that decision today? Can we get an idea of what the accuracy is when we do it manually, or we do it with a lot of intuition and gut feel? It's another way to figure out when a model is ready to be deployed. Okay, so we built a couple of models. Now we're ready for our third step in the process, which is model deployment. I click the export option here, and you can export one or both of these models if you so choose. You notice right off the bat, even though we're using open source R in our product to do the model building and model creation, we actually export the models without using R. If you drop this box here, you can see that you've got some choices for how you want to deploy the model. Typically, people will deploy them as C, and we'll compile that into a function inside of WebFOCUS, but you also can deploy that model as a Java file for Hadoop. PML is predictive modeling markup language. There's some downstream systems that consume PML, and we also could deploy the model as a Teradata user-defined function, so you could do in-database scoring. So I choose the export file type, and I can give this a name. I can call it whatever I like as long as it's .c. So you typically would name it something, decision tree churn class, and the class is checked here. That's going to predict the churn yes, no, or 0, 1. And then you can also ship out a second model, which would be decision tree churn probability. So you can actually get the likelihood or the score between 0 and 1 of that prediction. That really helps an end user to be able to interact with that predictive result. So I can, again, export those one or two models. I click Save, and that's what WebFOCUS RStat is all about. Explore the data, visualize it, do some data transformation, build a couple of different predictive models, evaluate those models, but most importantly is to get that model exported. I come back to Application Studio, where I'm going to now build a report for someone. But in that report, I want to utilize the predictive score. So at first, I want to do a model deployment. And I can just click on I'll just choose a C file here. And then I can pick my deployment location and click deploy. I of course, would be browsing for my churn model there, or whatever model you've built, maybe for target marketing, maybe for risk, maybe for manufacturing. You're effectively deploying this model in this form as a DLL, dynamic link library. Windows could be, it'll be deployed as a .so if you're working on Linux. So that's the second step. Build the model first, export it. Second step is actually to deploy that model. Now, that model is ready to be added to this report. And what we do is add that model to a new report by way of a computed field. Let's say new computed field. Call this whatever you like, typically score, predict. And once you go to functions, you'll see this refresh scoring routines, and it shows me all of the predictive models I have access to on my WebFOCUS server. So I'm going to scroll down and find my customer churn example. And I'm going to map over the variables that are needed. You see I've got two models here, churn class and churn probability. Remember the three variables that we saw that were needed. This is saying for new people, for new customers, if you pass over to me these parameters of their age, their marital status, and the years of current job, I can supply you with that prediction or that likelihood that they're going to cancel their account. Well, here's my data on the right. Again, I've moved out of predictive modeling mode and I'm now in business intelligence mode, creating a report for someone, and this data could be coming from anywhere within the organization, one or multiple sources that I've joined up in our business intelligence platform. And I simply drag and drop from right to left, age, marital, years of current job, whatever input variables are needed. And what that ends up creating is computed fields. So now I've got computed fields here. If we roll over this, you'll see this is the model, churn class, parentheses, here are my arguments separated by comma. So there's age here, comma, marital status here, comma, and then here's the current job. And then predicted underscore churn, that's the name of the new field that will be added to the report. So it's crucial to note that we're not just sharing data from the predictive model and then reporting off it. This is true predictive model integration because this is an actual function, and what that ensures is that for your end users, so imagine the people in marketing and promotions, maybe in risk, they want to make sure that as their underlying data changes, it could change every day, when they run that report, they know that they're getting updated scores. So you can see predicted churn here is a computed field along with the likelihood. You can actually see them here in the report. And now, right at runtime, when we run that report or when you schedule it to run, those predictive models fire. It could be a set of rules, it could be a regression model, it could be a neural network. It's creating new columns in a report. Predicted churn with yes, no, and then associated likelihood right next door. So now you've got the building blocks to create interactive, visual, WebFOCUS applications that you can add graphics to. You could put the predictions on a map. You could stoplight them. You know, red is anything greater than 70%. Yellow is 30 to 70%, and then green is below 30%, something like that. You could deploy this any way that your business end users need, so that that information just looks like another piece of information coming to them, and create visualization. You could create maps. You could put slider bars. You could also make them interactive where you could sort and filter, and people make decisions such as, you know, who is most likely to churn? Well, that's a simple filter, or maybe a parameter that's just showing everybody with a likelihood of churn of greater than 90%. And then you can add another predictive model to it that says what's their predicted future value. So you could really hone in on what kinds of promotions and marketing efforts you want to roll out to retain those customers. So that was a quick overview of our platform, WebFOCUS RStat. Again, platform approach of covering data access, data manipulation, data wrangling, data quality, make sure that data is trusted, building predictive models, no code, no syntax with WebFOCUS RStat, and finally, deployment of that model directly into an end user application. I want to thank everyone for their time today. Bruce Kolodziej again here with Information Builders. Certainly reach out to me for any follow-up discussions, or reach out to your local Information Builders account executive. Thanks everyone again for your time. Have a great rest of your day.